Welcome to today's deep dive. Buckle up, because we're diving headfirst into the incredible world of ancient Roman engineering.
I'm excited to dig in.
Yeah, we're talking way more than togas and gladiators.
Right.
We're going deep with this article titled The Engineering Marvels of Ancient Rome. And get this, you might be surprised to learn that ancient Rome wasn't all about emperors and conquests. They were seriously innovative, like way ahead of their time. Their engineering feats still impact us today.
It's true. The Romans had this incredible knack for not just conquering vast lands, but actually reshaping the world around them. Their engineering wasn't just about function. It was about making a statement, showcasing their power and ingenuity. They wanted the whole ancient world to see what they were capable of.
Totally. We're talking roads that have lasted millennia. Aqueducts still standing today.
Unbelievable.
And get this, an arena they could flood for mock naval battles.
Oh, yeah, the Colosseum.
That's almost hard to believe.
And, you know, what's even more impressive is that they achieved all this without the tools and technology we take for granted today.
I know, right? It makes you wonder what they could have accomplished with modern tools. Let's start with their mind-blowing road system.
Yeah.
I was floored when I learned their road network spanned over 400,000 kilometers.
Wow.
That's like driving from New York to Los Angeles and back, over 30 times.
That's a lot of road trips.
I know, right? And these weren't just dirt paths, right?
Absolutely not. Roman roads were meticulously engineered and built to last.
They definitely were.
They used this layered approach to construction, starting with a foundation of large, heavy stones, like a backbone, for stability.
To keep everything from sinking, basically.
Exactly.
Yeah.
On top of that, layers of gravel and sand, and finally those iconic large, flat paving stones.
And ones we always picture.
Precisely.
Oh, right.
This system was genius. It efficiently distributed weight, provided drainage, and created this super durable surface that could handle heavy traffic and the elements year after year.
And to think, some of these roads are still in use today.
I know.
It's mind-blowing.
Yeah.
Can you imagine walking on the same path as a Roman soldier or a chariot? Talk about a connection to history.
It gives you chills, doesn't it?
Yeah. It really shows the long-lasting impact of Roman engineering. Their roads weren't just about getting from point A to B. They were the veins and arteries of the Roman Empire, facilitating trade, communication, the swift movement of troops.
Essential, really, for holding such a vast empire together.
Totally. But roads alone couldn't sustain a city bursting with over 1 million people.
Of course not.
And he needed something else.
Yeah.
A constant supply of fresh water.
A necessity.
How did they manage that?
Aqueducts. They're iconic aqueducts. These weren't just pipes, mind you.
I have about to say.
They were massive engineering projects, often spanning huge distances, incorporating bridges, tunnels, sophisticated systems to maintain a constant flow of water.
All using gravity.
Precisely. A prime example is the Aqua Claudia. It stretches over 69 kilometers and delivered a staggering 50 million liters of fresh water every single day.
That's mind-boggling.
Absolutely remarkable.
The Aqua Claudia is impressive, no doubt. But I have to say, the Pont de Garde in France, that one really captures the imagination.
Oh, it's beautiful.
A stunning structure still standing today, carrying millions of liters of water over 50 kilometers. It's hard to believe they built something like that back then, with no modern tools.
It really speaks to their ingenuity.
Doesn't it? They had a deep understanding of physics, mathematics, and they were masters of working with the landscape, shaping it to their needs.
Exactly. They used human ingenuity, animal power, and surprisingly simple tools like ropes, pulleys, levers, and rollers to move massive limestone blocks.
It's incredible to think about.
The planning, the coordination.
Just to execute a project like that back then is mind-blowing.
It's a testament to their dedication and skill.
It really is. And they weren't just relying on brute force. They had to survey the land carefully, figure out the most efficient routes, and let gravity do its thing.
Right. Maintain that consistent downward slope to keep the water flowing.
Genius. These aqueducts are a powerful symbol of the Romans' ability to harness the forces of nature.
Absolutely. To bend the natural world to their will.
Exactly. But let's move on to another iconic structure.
Okay.
One that screams Roman power and entertainment. The Colosseum. It wasn't just a stadium, right? It was an architectural marvel.
Absolutely. The Colosseum wasn't just about gladiatorial combat, it was about showing off, showcasing Roman engineering, captivating the masses. Imagine 80,000 people roaring with excitement as gladiators clashed.
It must have been a sight to behold. What always gets me is what lies beneath the surface.
The hypogeum.
Yes, Tell me everything.
It's a hidden world, literally beneath the arena floor.
I know.
A labyrinth of tunnels and chambers. That's where they house the gladiators, of course, the animal,
Right.
the props, all the machinery needed to stage these incredible spectacles.
Mhm.
A hive of activity down there, orchestrating all the drama and spectacle unfolding above.
It's crazy to think about. And we can't forget the most unbelievable feature,
Which one?
their ability to flood the arena for mock naval battles.
Yeah.
How do they pull that off?
It's incredible, right? A real testament to their understanding of hydraulics.
It is.
They had this complex system of channels and sluices that let them flood and drain the arena incredibly efficiently. They literally brought sea battles inland just to entertain the crowds.
I can't even imagine the logistics.
It's a remarkable feat. Shows their ambition and their engineering genius.
I know. We've talked about the scale and grandeur of Roman engineering, but what really caught my eye is their concrete. It's not just regular concrete, is it?
You're right. The Romans developed this incredibly durable concrete mixture. They called it opus caementitium.
Try saying that 3 times fast.
I know, right? And unlike modern concrete, it actually gets stronger over time, especially when exposed to seawater.
Wait a minute. They accidentally invented super concrete.
It does seem too good to be true, doesn't it? This unique blend of volcanic ash, lime, and rubble. It allowed them to build structures that have withstood the test of time, literally.
Structures built 2,000 years ago, still standing strong today.
It's incredible. It's a true testament to the amazing properties of their concrete.
It makes you wonder if we've lost some of that ancient knowledge.
I've wondered that myself.
Speaking of which, is the Pantheon the ultimate example of their concrete technology? I mean, that dome is massive,
It's breathtaking.
and it's built entirely of unreinforced concrete. It's still the largest of its kind, even today. I can't even wrap my head around how they accomplished that.
The Pantheon. It's a masterpiece of Roman engineering. The fact that it stood for nearly 2 millennia through earthquakes, weathering.
It's amazing.
It's unbelievable. It speaks volumes about their understanding of material science and structural design. They weren't just building structures, they were creating legacies.
I think you're right. The Pantheon is definitely a must-see for anyone visiting Rome. But Roman engineering wasn't all about grandeur and massive structures.
Oh, no, not at all.
They also knew how to live well.
They did.
Their bathhouses are a great example. Tell me, what was the purpose of these ancient wellness centers?
Roman bathhouses, or thermae, were so much more than just places to get clean.
I've heard that.
They were essential to Roman social and cultural life. Spaces to unwind, socialize, exercise, even engage in intellectual pursuits.
Like a one-stop shop for health and entertainment.
Exactly. Think of it like a modern gym, spa, library, and social club all rolled into one.
It's like a pretty good time. And I hear they were heated even in the winter using a system called a hypocaust.
That's right. The hypocaust was a marvel of innovation. Think underfloor heating. But in ancient Rome,
Nice.
they created a space beneath the floors, sometimes even within the walls, where they could circulate hot air from a furnace. Kept those bathhouses warm and toasty even during the chilly winter months.
Pretty clever. It's amazing how they created such a comfortable, luxurious experience with such simple technology. But we've covered roads, aqueducts, the Colosseum. They're super concrete. Even bathhouses. What about sanitation? We can't forget that.
You're absolutely right. The Romans understood the importance of public health and sanitation.
They did.
Their sewer system was one of the earliest and most effective in the world. The Cloaca Maxima, meaning greatest sewer in Latin, is a prime example.
So they were thinking about hygiene and public health long before modern sewage systems.
Centuries ahead of their time, they were. But how did this Cloaca Maxima actually work?
Yeah, I'm curious.
Well, it started as an open drainage canal, but it was gradually covered and expanded into this complex network of tunnels and channels carrying wastewater out of the city. They even used the aqueducts, cleverly, to supply fresh water to help flush the system.
So they were multitasking.
In a way, yes. This kept the city surprisingly clean for that era, considering we're talking about a population of over 1 million people.
It makes you wonder if modern cities could learn a thing or two from the Romans.
Perhaps.
We've covered a lot of ground already, but before we wrap up part 1,
Okay.
I have to ask about Caesar's Rhine Bridge. A bridge built in just 10 days.
It sounds impossible, doesn't it?
It does.
But it happened. It's a testament to their logistical and engineering brilliance.
It really is.
Julius Caesar, to make a bold statement, decided he needed to cross the mighty Rhine River. So he ordered a bridge built, and his engineers responded with incredible speed and efficiency.
They did.
They finished that bridge in just 10 days.
10 days. I can't even get a plumber to return my calls in 10 days.
How'd they do it? Did they have, like, prefabricated parts, some ancient IKEA bridge kit?
Oh, no IKEA back then.
Right.
Their secret was brilliant planning, pre-cut timbers. They had a highly skilled workforce and a clever design using angled wooden piles driven deep into the riverbed to withstand the currents.
So they knew what they were doing.
They did. It was a temporary structure, meant to send a message, not to stand for centuries. A temporary display of Roman power and engineering brilliance, built and dismantled with astonishing speed. It just shows what they could achieve when they set their minds to it. I'm already blown away by the sheer scale and ingenuity of Roman engineering, and we've only scratched the surface. Welcome back to our deep dive into the fascinating world of ancient Roman engineering. In part 1, we were blown away by the scale and ambition of their projects. Now I'm ready to roll up my sleeves and dig into the nuts and bolts. What made these structures so incredibly durable? What secrets do they have at their togas?
It's one thing to look at these ancient wonders from afar, but when you really get into the details, the nitty-gritty, you gain a whole new level of respect for their ingenuity and the craftsmanship involved. Let's revisit those impressive Roman roads for a moment.
Okay.
Remember, we're talking about a network spanning over 400,000 kilometers, with many sections still in use even today.
It's hard to even grasp. So how did they actually build these roads? Was it as simple as just like throwing down some stones?
Oh, no, not even close. They had a very systematic and pretty sophisticated approach to road construction.
Really?
Oh, yeah. They knew durability was key. I mean, think about it. The volume of traffic, the variety of terrain they had to deal with, they had to build to last.
So spill the beans.
Yeah.
How did they build a road that could withstand centuries of wear and tear? What was their secret formula?
Their not-so-secret weapon was a multi-layered approach. That's what ensured stability and proper drainage.
Okay, layers, like lasagna.
Kind of. Picture this. First, they dig a trench, sometimes like a meter deep, sometimes even more.
Wow.
Then they fill that trench with large stones. That's your base layer, your foundation.
Makes sense. Keeps the road from sinking into the mud.
Exactly. It acts like a backbone, providing that solid base and preventing the road from, sinking or becoming all uneven over time. It had to be strong enough to take the weight of heavy carts, chariots, marching legions all day, every day.
I'm starting to understand. So it was a lot more than just laying down some pretty paving stones on the ground.
Way more. A lot of thought went into creating that sturdy foundation.
So we've got the large stones as the base layer. Then what?
Then on top of those big stones, they'd add a layer of smaller stones, or gravel.
Okay.
This helped to distribute the weight even more effectively and create a more level surface. It's like building a house. You need that solid foundation, but then you have to carefully add layers on top to make sure it's stable and will stand the test of time.
That's a good analogy. So large stones, smaller stones. What's next?
The next layer was sand. And sometimes they'd even use a primitive type of cement.
Cement already back then.
This acted as a binder, holding everything together and creating a nice, smooth, even surface for the final layer.
And that final layer was those famous, large, flat paving stones, the ones we always see in pictures.
Exactly. And they fit those paving stones together so carefully, often with incredibly tight joints. That's what gave those Roman roads their durability and that surprisingly smooth surface.
Pretty impressive when you consider they didn't have lasers and power tools back then.
Right. Makes you appreciate the skill of those Roman engineers.
It really does. And it's not just the roads that have stood the test of time, the aqueducts too. Another testament to Roman engineering that still blows my mind.
Absolutely.
We talked about the Aqua Claudia and the Ponte Guard in part 1, but what about the process of actually building those massive structures? I mean, how did they manage to transport those gigantic blocks of stone and build those towering arches without cranes and bulldozers?
That's the question that keeps historians and engineers up at night. They achieve these amazing feats through a combination of human ingenuity, animal power, and a mastery of simple machines. We're talking levers, pulleys, rollers, ramps, basic tools, but used in really innovative ways.
So lots of sweat and muscle power.
Oh, yeah. They would use ropes, pulleys, and teams of oxen or horses to drag those enormous blocks of stone from the quarries all the way to the construction sites.
I bet that was a sight.
And to lift those heavy stones into place, they built these elaborate wooden scaffolding structures and used systems of ramps and wedges.
So they just slowly inched those blocks up higher and higher.
Precisely. It must have been a very slow and painstaking process, but it worked.
I can't even imagine the logistics involved. How did they ensure everything fit together perfectly without precise measuring tools?
That's where their meticulous planning and skilled labor came in. They had a deep understanding of geometry and physics, and they had a really keen eye for detail. And they were masters of working with the landscape. They knew how to adapt their designs to fit the natural terrain.
It sounds like they were a lot more in tune with nature than we are today.
I think there's something to that. And remember, building the aqueducts wasn't just about transporting those huge stones. They also had to deal with the challenge of the water itself. How do you ensure a consistent flow of water over such long distances, up hills, through valleys?
It's mind-boggling. How do they do it?
That's where their understanding of gravity and hydraulics really shines. They knew that to maintain a consistent flow, they needed to maintain a gentle slope. So they would meticulously survey the land, figure out the most efficient route, and then build the aqueducts on arches and bridges to maintain that slope, even when the land was uneven.
So they were basically working with gravity, not against it.
Exactly. No pumps or artificial pressure systems, just the natural flow of water downhill.
Pretty genius when you think about it.
And it wasn't just about transporting the water. They also had to think about filtration and distribution once it reached the city.
Of course. So how did they make sure the water was clean and get it to where it was needed?
They built settling tanks and filtering systems, often using layers of sand and gravel to remove impurities from the water.
Like a giant Brita filter.
Pretty much. Then they created intricate networks of lead pipes and channels to distribute that fresh water all throughout the city.
So to public fountains, bathhouses.
Yep, and even to private residences in some cases.
Wow. The complexity of this system, it's just incredible for that time period. It really highlights their commitment to public health and the well-being of their citizens.
Agreed. And speaking of well-being, let's go back to those bathhouses for a moment. We talked about the hypocaust heating system in part 1, but there's so much more to discover about these ancient wellness centers.
I'm all yours.
Roman bathhouses were like the social hubs of their time. They offered a space for people of all classes to come together, relax, and engage in all sorts of activities.
So it was like a combination of a modern gym, a spa, and a social club.
You got it. A typical Roman bathhouse would have a series of rooms, each with a different temperature. You'd have the frigidarium, which was the cold room, the tepidarium, the warm room, and the caldarium, the hot room, sort of like a modern sauna circuit.
A Roman sauna circuit, I like that.
It's a great way to describe it. And many bathhouses even had swimming pools, exercise areas, massage rooms, gardens where you could stroll and chat with friends. It was a very holistic approach to health and well-being.
And all this was available to everyone.
Pretty much. Even the poorest citizens could afford to visit the public bathhouses, which were often subsidized by the government.
That's amazing. They really were ahead of their time in many ways. It sounds like they understood that a healthy population was crucial for a strong and prosperous society.
Definitely. And their bathhouses were a testament to that belief.
We've covered roads, aqueducts, bathhouses. Now let's get down to the, well, not so glamorous, but equally important aspect of Roman engineering, their sewer system.
Let's do it.
We briefly touched on the Colloca Maxima in part 1, but I'm dying to know more about the specifics. How did they build such a vast and intricate underground network? And how did they keep it all running smoothly?
The Cloaca Maxima, the greatest sewer, is a marvel of engineering, especially when you consider it was built centuries before modern sewage systems.
Hard to believe.
It started as a simple open canal just to drain the marshes around the Roman Forum.
Makes sense.
But over time, it was covered and expanded into this complex network of underground tunnels and channels to carry wastewater away from the city.
What a huge undertaking.
Oh, it was. Imagine digging through all that rock and soil, often in confined spaces, without modern equipment.
I can't even imagine.
Backbreaking, dangerous work. And then they had to figure out the right slope for the tunnels to ensure efficient drainage. Too steep, and the water rushes through too quickly, causing erosion or blockages.
And too shallow.
The water would stagnate. That creates a whole other set of problems.
So it was a delicate balancing act.
Absolutely. They needed skilled engineers and a dedicated workforce to keep everything flowing as it should.
So did they have specialized sanitation workers in ancient Rome?
They did. Teams of workers were responsible for inspecting and maintaining the sewers, clearing blockages, and making sure the whole system kept ticking.
Not the most glamorous job.
Definitely not,
Yeah.
but absolutely essential for the health and sanitation of the city.
The unsung heroes of Roman engineering. It's a good reminder that even the grandest structures and systems wouldn't function without those who worked tirelessly behind the scenes to maintain them.
Very true.
We've covered so much ground in this deep dive: roads, aqueducts, bathhouses, even sewers. And I'm finally starting to wrap my head around the sheer scope of Roman engineering.
It is impressive.
But I feel like we've only scratched the surface. What other wonders await us in part 3?
Well, we've talked about how durable Roman concrete is, but we haven't explored specific structures that showcase its full potential.
Right.
I think it's time we finally delve into the Pantheon.
The Pantheon. I can't wait.
This building has stood for almost 2,000 years, and that massive, unreinforced concrete dome, it's awe-inspiring.
It almost seems to defy gravity. I'm ready to learn how they pulled it off.
And speaking of defying gravity, we should also spend some time talking about Roman bridges.
Bridges, yes.
They were true pioneers of bridge building, constructing some of the longest and most impressive bridges in the ancient world.
I can't wait to hear about them.
Their techniques and materials are still inspiring engineers today. So get ready for part 3, where we'll visit the Pantheon and explore the world of Roman bridge building. It's going to be epic.
Welcome back to the final leg of our Roman engineering adventure. We've explored those incredible roads, aqueducts, bathhouses, sewer systems, the whole shebang. Now it's time for the grand finale, the pièce de résistance.
I like where this is going.
The Pantheon. This building has stood for almost 2,000 years. Talk about a testament to Roman ingenuity.
It truly is an icon.
And it's a shining example of their mastery of concrete. That stuff continues to blow my mind.
Roman concrete, or opus caementitium, it deserves all the praise.
Definitely. As we discussed, it doesn't just resist time, it actually gets stronger with age, especially around water.
The Romans were ahead of their time with this stuff.
No kidding. It's almost like they stumbled onto a recipe for a super material. It's why structures like the Pantheon are still standing today.
It's a big part of it, for sure.
But the dome itself, that's what gets me. It's a gigantic, bigger than a football field, and it's made entirely of unreinforced concrete.
It's a marvel of engineering.
I can't even imagine how they conceived of something like that, let alone built it 2,000 years ago.
The Pantheon's dome is still a source of wonder, even for modern engineers. You're right, the fact that it's unreinforced concrete is a testament to their understanding of material science and their willingness to push the limits. They weren't afraid to experiment and innovate.
So how did they do it?
Yeah.
What were some of their tricks, their innovations that allow them to build a dome of this scale without using steel reinforcement or anything like that?
Well, one key innovation was how they changed the concrete mix depending on where it was used in the dome.
Oh, that's interesting.
At the base, where these stresses are the greatest, they used a heavier aggregate.
What's an aggregate? Sorry.
Oh, it's the stuff mixed in with the cement. In this case, they used travertine, a strong volcanic rock. As you move higher up the dome, they gradually switch to lighter materials like pumice and tufa.
Ah, so it gets lighter as you go up. Makes sense.
This reduced the overall weight and stress on the structure. It's a brilliant approach.
So they weren't just pouring concrete randomly, they were really thinking about it, engineering each layer.
They were masters of their craft. They carefully considered weight distribution and stress throughout the entire dome.
Amazing. And those coffers, those recessed panels in the dome, they're not just decorative, are they?
Absolutely not. Those coffers served a dual purpose. They reduced the weight of the dome, of course, but they also added structural support.
Form and function, all in one.
The Romans knew how to combine practicality with aesthetics. The Pantheon is a perfect example of that. It proves that engineering can be an art form.
I'm with you on that. And speaking of art and engineering, let's switch gears to another area where the Romans truly excelled.
Bridges.
Bridges. They were pioneers in bridge building, creating some of the most impressive spans in the ancient world.
Their bridges were feats of engineering and works of art.
I've always been fascinated by Roman bridges. They have this strength, this elegance. They just blend into the landscape.
Mm-hmm.
And they show how the Romans could overcome any obstacle, even a raging river. That made their bridges so special.
Their mastery of the arch was crucial.
The arch, of course.
They understood the inherent strength of that shape, and they used it to create bridges that could span vast distances and carry enormous weight. Take the Alcantara Bridge in Spain. It's been standing for nearly 2,000 years.
Wow. The Alcantara Bridge. Tell me more.
Picture this. 6 massive granite arches soaring over 60 meters above the Tagus River.
It sounds breathtaking.
The arches are constructed with incredible precision, each one working together to distribute the weight and withstand the forces of nature.
It must be incredible to see in person.
It is, and to think it was built without modern tools or heavy machinery. It's a true testament to Roman engineering at its finest.
They really didn't mess around, did they?
Yeah.
And it makes you realize they weren't just building things, they were building legacies.
Yeah.
Things that would last for centuries and inspire generations to come.
They shaped the world around them in ways that we still feel today. And that's the real legacy of Roman engineering. It wasn't just about conquering lands, it was about transforming them.
Well said. It seems like they had this deep understanding of not just engineering principles, but also of their materials, the landscape, the forces of nature. It's really inspiring.
Their roads, aqueducts, bridges, all of it, it stands as a monument to their ingenuity, their determination, and their belief in human potential.
As we wrap up our deep dive into the world of ancient Roman engineering, I'm left feeling a sense of awe and a renewed appreciation for the power of human innovation. They accomplished so much with so little, relatively speaking. It makes you wonder what they would think of our modern marvels. And what can we, in the 21st century, learn from their approach to problem solving? These are questions worth pondering as we continue to explore the world around us and marvel at the wonders, both ancient and modern, that make up our world. Thanks for joining us on this journey through time.